Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. So in this video I would like to explaining onto the MCQs on milling machines, and this is our session number 5. So before starting this session, first of all subscribe my channel for the special kind of preparations for GAT, UPSC and all kind of government examinations, and you will also find some of the fundamental concept about mechanical engineering. So now we will start with our question number 1. Which of the following will result in best surface finish of job? Option A, up milling. Option B, conventional milling. Option C, down milling. And option D, none of the mentions. So basically, for getting a best result in case of the surface finishing onto the job, so the down milling process that will be more preferred, because in case of the down milling process, at the initial stage that will be the requirement of the higher amount of cutting force, as well as that will be the larger chip thickness is possible. At the end of that particularly down milling process, that will be the minimum chip, so the less amount of force is being required, so you can easily performing your operations with the higher accuracy, or you can say good surface finish. So the right answer is C, down milling process. So if you want to learn in detail between the basic difference between up milling and down milling process, so you will find a link in my description box. The next question: which of the following milling operations will require lower force of the cut? Option A, up milling process. Option B, climb milling process. Option C, down milling process. And option D, none of the mentions. So just you can see, we already discussing for the down milling process. So in case of the down milling process, at initially that will be the maximum chip remove, at the end that will be the minimum. So that will be the reverse in case of the up milling process. So this is for the down milling process. Now in case of the up milling process, so just you can see, so at initially, so that will be the minimum, but that will be at initial, and maximum at the end of the stroke. So in case of the up milling process, that will be the requirement of the larger amount of force, because at initially that will be the minimum, but at the end of the cut that will be the maximum force is being required. So in case of the requirement of the lower force, so once again that will be the down milling process. So the right answer is C, down milling. The next question: dividing head is generally used for changing the angular position of workpiece relative to the milling cutter. So that will be the right sentence. So the right option is A, true. Then next: circumference of a workpiece is to be divided into 60 equal divisions using simple indexing method having a 40 worm wheel teeth. So the indexing movement will be option A, 12 holes on 18 hole circle. Option B, 16 holes on 18 hole circle. Option C, 12 holes on 21 hole circle. And option D, 16 holes on 21 hole circle. So just you can see, for simple indexing method, that will be equal to 40 by n. So 40 divided by n, and that will be equal to equal divisions is required. So 40 divided by 60. So you will get 2 by 3 fraction for the indexing. So just you can see which kind of whole circle system is being preferred. So just you can concentrate onto the options. So here that will be the 12 holes into 18 hole circle, 16 holes into 18 hole circle, 12 holes into 21 and 16 holes into 21. So just you can see 18 hole circle system is being adopted. Either you should adopt a 21 hole circle system. So let us see for the first 18 hole circle system. So just you can see 18. So 6. So 6 multiplied by 2, that will be the 12. So that will be indicating as a holes movement into 18 hole circle system. So that will be the possible like this, 12 holes on 18 hole circle, that will be the right answer. So the intimation of this, and that will be the 12 holes on 18 hole circle is required to be dividing into 60 equal number of divisions. So let us check with the another. So the second is not possible. Then 21. So just put the value instead of 18 and that will be the 21. So just you can see 2 by 3 into 21. So 7. So 14 holes into 21 whole circle system. So the 14 holes is not available. So C is not possible, D is not possible. So the right answer is option A, 12 holes onto 18 whole circle systems. So if you want to learn in details onto the simple indexing methods, so you will find a link in my description box. The next question. Peripheral milling is well suited to the cutting of option A, deep slots, option B, threads, option C, gear teeth, and option D, all of the above. So that will be the applications of peripheral milling machines or milling cutters. So you can make a deep slots as well as threads, or you can also make a gear teeth. So according to this option, the right answer is D, all of the above. The next question. A milling cutter may have surfaces made of option A, high speed steel, or you can say HSS, option B, cemented carbide, option C, aluminum oxide, and option D, both A and B. So basically milling cutters, it may be made by the high speed steel as well as cemented carbide materials. So both are using for making a surfaces onto a milling cutter. So the right answer is option D, both A and B. The next. The use of coating on a milling cutter will increase the which kind of characteristics of the tool? Option A, surface hardness, option B, corrosion resistance, option C, surface finish, and option D, melting point. So basically the coating onto the milling cutters, that will be increasing the surface hardness of the tool. So your outer surface is being harder by the coatings. So that will be also depends upon which kind of coating material is being used, but it will be makes a harder surface. So the right answer is option A, surface hardness of the tool. The next. Gang milling refers to the use of two or more milling cutters mounted onto the which arbor in a which kind of milling setup? Option A, same arbor in a vertical milling. Option B, same arbor onto the horizontal milling setup. Option C, different arbor in a vertical milling setup. And option D, different arbor in horizontal milling setup. So basically gang millings refers to the horizontal kind of milling setup. So the right answer is either from A or B. So in case of gang millings refers to the use of the two or more milling cutters mounted onto the same arbor. So on a single arbor you will attach a more than two or more milling cutters is being used. So onto the same arbor in a horizontal kind of milling setup. So the right answer is option B. Then next, in the vertical mill, milling cutters are held in the which and which? So the option A, spindle and rotates on its axis, spindle and reciprocates. Option C, in the arbor and rotates on its axis. Option D, in the arbor and reciprocates. So basically that will be not reciprocates. So B and D is not possible. So just you can concentrate in the vertical mill. The milling cutters are held into the spindle because that will be into the vertical axis. So held into the spindle and basically rotates on its axis. So the option A. So in vertical milling that will be used as a spindle. If it will be the horizontal, so that will be into the arbor. So here that will be the vertical milling, so it will be cutters held into the spindle. So if you want to learn in details of the construction of vertical milling machines, so you will find a link in my description box. Then next question, milling machine can hold which cutters at a time? Option A, only one. Option B, only two. Option C, only three. Option D, none of the mentions. So according to the milling machines, you can use multi cutters. So according to my requirements of the shape and size of the jobs, you can use more than 2 or 3, or you can say in case of the gang millings up to the 6 number of cutters you can also use. So not only 1, not only 2, not only 3, or none of the mentions. So according to these given options, the option D, none of the mentions. So if you like this, then subscribe and share Modi Mechanical Engineering tutorials. Thank you so much and keep watching.